Liz Williams, and I'll be introducing our keynote speaker for tonight. Before I do that, though, I'll remind you that this session will be recorded, and I'll ask that everyone hold their questions until Benedetta's talk is finished. So with that, I'm very pleased to invite Benedetta Brevini to the stage. Benedetta is a journalist, media activist, and associate professor of communication at the University of Sydney. Before joining the Academy, she worked as a journalist in Milan, New York, and London for CNBC and RAI. And her latest book, published by Polity, is called Is AI Good for the Planet? Her talk is titled AI and the Climate Crisis, Rethinking the Relationship Between Artificial Intelligence and the Planet. Welcome, Benedetta, and thank you so much for joining us today.
Thank you, and thank you so much for your invite, and especially to you, Liz, for organizing this incredible event, the social responsibility of algorithm. So I'm hopeful that you can already see my slide, and I would like to start with a reminder that, of course, the global pandemic and the recent climate emergency, the recent warnings coming from the IPCC have underscored the need for us to rethink the type of economy and also the type of society we want to build as we face a worsening climate emergency, and the continuous calls coming from the IPCC have made this very urgent. And of course, Europe is leading the way in developing strategies for green recovery. And we all know, and I'm sure that you're very familiar with this, that, for example, already in May 2020, the European Council have approved, alongside with the recovery package, this further 0.74 billion long-term EU budget for a 2021-2027 recovery. And these are actually very important milestone for Europe that actually have to make us really rethink the type of society, the type of economy that we want to develop, especially considering the incredible relevance of digital technologies in all the ideas that are being developed of green transitions and green resilience. And while all of this is unfolding, of course, we see that at the same time, we see a clear development and a clear push in the development of artificial intelligence as considered as a key, really a key driver of any kind of strategic invention, strategic innovation, and the digital services being developed. At the same time, what I'm sure that you are noticing is that all these debates that are taking place concerning the green recovery and concerning the incredible relevance of AI development are really constantly taking places in very distinct fora. So the technology fora on the one hand, and then, you know, we have the environmental concerns and environmental discussions on a very different route and a very different path of discussion. And the idea of this talk, and also one of the crucial idea of one of my latest book, is that is entitled, of course, Is AI Good for the Planet, is really to try to bridge this disconnect. And in doing so, I actually feel that we need to really start redeveloping a new understanding of the relationship between AI and data-driven communication systems in a way that the climate emergency can become and can have a center stage. And the crucial question then become, what are the environmental damages? What are the environmental costs of the development, the technological development that we are pushing? And of course, like, in order to do that, and this really should be for scholars, especially scholars in my field, but also beyond communication and scholars of political science, for example, but also in the field of the environment, we should really start redefining and starting with a redefinition and reclaiming a new definition of AI, for example, is, in my view, and I'm arguing in the book, the way forward. So, like, how can we reassess and reclaim and redefine AI in a way that it allows us to really consider the climate emergency that we're all witnessing, and also in this way probably move forward and embrace this idea of rethinking the kind of society and economy we want to develop. So as we know, and I'm sure that are very familiar with these definitions, AI in mainstream debate has always been defined as this sort of disability of human, of machines to really mimic humans, to mimic and perform human cognitive functions. And of course, this has always traditionally in mainstream debate, included from problem solving, decision making, reasoning, and any kind of attempt to even match emotions, for example. And I'm sure that you're all familiar with what's happening, what's happened in the last couple of days with the idea that of a sentient, kind of AI that being developed, and the reaction of Google immediately to actually seize, the conversation. But in any case, like we see that constantly AI is really offered as the divine hand that is offering the solution to the greatest challenges of our time. So greatest challenges started with chronic diseases, great help with the pandemic, great help in repairing the economy, great help in addressing the climate crisis or addressing huge security concerns. And I'm fascinated, of course, by all these discourses around AI that have a lot to share with the history of technological discourse. And I'm not sure if you're familiar with the work, for example, of Vincent Mosco, and the work of course, like, even Gramsci and Barth, and the relevance of myth in developing dominant ideologies of our time that then become so normalized in our everyday conversation that it becomes almost impossible to be able to challenge them. And in this way, by building this myth, and I use often the word techno mythologies, or I use the word of the techno magic to talk about this myth. And AI is certainly not immune to this type of discourses that in a way are allowing us to imagine something that is not yet here, because it's always coming to us to save us and to rescue capitalism, to rescue the planet in a way that it almost seems that it will be in the future and never really in the present. And this is a great, actually, rhetorical also device and technological device, to try to bring away actually a conversation on actually what AI really is. And of course, and I'm arguing in the book, Is AI Good for the Planet? What is actually crucial if we want to understand and address this major problem that we're facing, the climate crisis that IPCC reports, even in the last year, have deemed to be, of course, accelerating in a way that was even never predicted in the last 15 years. And we know that we are on a trajectory for a 3 degrees Celsius, and we know that we need to reduce by 50% the carbon emissions if we want to meet the famous target of the 1.5 degrees Celsius. And yet we are still talking about AI in this applying this magic thinking around it. And so what I claim and what we need to do is redefine AI by adopting a definition that embraces its materiality and actually really understands AI in a different way that will refocus on the infrastructures, the material devices, the assemblages of machines that actually are the crucial components of AI. And as I was looking, of course, at major mainstream definitions, I actually found that one of the most useful working definition for me, trying to understand what AI really is, and in this way, trying to understand and go deep into the relationship with the climate crisis, has been to one of the white paper, EU white paper on artificial intelligence, that really talks about AI as a collection of technologies, and also brings in, of course, the relevance of data, algorithms, and computer power. And also, in this way, is capable of explaining really clearly the relevance of data capitalism, the acceleration of data capitalism in all of this. You know, we wouldn't have had this incredible acceleration of AI if it wasn't for the acceleration of the data extractionism, and that is, you know, of course, characterizing the type of technologies that we are developing. And like, in a way, I think that this definition is a great starting point. But what is absolutely crucial is to like go back to the materiality and the components of AI, and therefore in critical political economy of communication, we are understanding AI as assemblages of technologies, as machines and in infrastructures. And if we finally focus on a definition of this type, then we can even understand the relationship with the climate crisis. And it's the only way in which we can then assess what are really the environmental costs and what are the environmental damages that can be associated with AI. If we keep using definitions that, you know, make of AI something that is almost untouchable, something that is not really material, then we can't really assess and connect with the climate crisis. Now, of course, it is important then to reinstate the way in which these machines, these infrastructures, of course, are depleting scarce resources and their production. So in the entire production chain, from production, consumption, and disposal, and of course, increase the amount of energy in their use and exacerbate all problems of waste and pollution. Now, I'm conscious of the time, but I wanted to give you a very clear example of at least 4 ways in which AI is connected to the climate crisis. And so we can then analyze this type of possible environmental damages, this type of environmental cost, and then address them. And in this way, bring back the AI policy discussions that are taking place and place the climate emergency at the center of AI development. So just as a start, and because, you know, also of the theme of the conference, like we have a fantastic study that has been done already in 2019 by the College of Information and Computer Science at the University of Massachusetts Amherst. And it quantified for the first time the energy consumed by running a very basic algorithm. And we know very well that it's difficult to make this type of generalization. And we know that, you know, I spoke to thousands of engineers as I was writing the book. And of course, they're claiming, how do you know exactly the type of neural networks that were used as development? But I find that this is a very important generalization that can make us understand the kind of energy consumption that it is connected to developing and training an algorithm. And like, as you can see from these slides, I mean, I think that if I told you that a common AI training model can emit up to 284 tons of carbon dioxide equivalent, probably you would be thinking, okay, what does it really mean? If actually as I did in this slide, I compare it with, you know, a simple flight, for example, between London to Rome, or a simple flight between London to New York, now we see the relevance of this type of energy consumption. We see the relevance of this type of carbon emission, because, you know, it's much more straightforward, right, to compare 284,000 kilograms, which is produced by, you know, the training of one model, with, you know, a flight between London to Rome, which produces 234. So this, in my view, already gives you an idea of the kind of problems that we have to address, and that we tend in European also debates around AI not to really place at center stage, because we tend to focus on the ethical problems, the problems of the biases, the problems, human rights issues concerning AI, which are of course very relevant, but also these problems are becoming crucial and urgent. But of course, you know, when I say, there are at least 4 ways, it's because, when we look at the algorithm, it's part of the problem. The other major issue, which is also something that is probably much more debated also in news media, is the problem of the sustainability of data centers. Now, we know that the industry has been working much more in this field than it has worked, for example, in trying to match and trying to measure the computational power of the algorithm. And we see often conversations on for example, the push and the drive by Microsoft on the one hand, or even by Amazon, to try to make the data centers more sustainable. But at the moment, because according to the World Energy Outlook, about 64% of our energy supply chain is still based on fossil fuels, then we still have a major issue, because data centers are still connected to the energy grid. So now some of them, of course, have started becoming independent and are starting really like using solar, for example, to be sustainable. But we know that data centers have a major problem also with the cooling system. If you go on a typical website of DeepMind, for example, now acquired by Google, like you will see that they list one of the primary sources of energy used in data center is cooling. So cooling of the water, major issue. Weather events, major issue. Having data centers in places that are suffering of major floods and drought. And I think that in Australia, I think we got a very clear idea what the constant weather events can do to the stability of a system. And of course, this is something that is rarely debated when we are talking about developing AI at the center of a green recovery. We see these debates taking place mostly in industry fora, because the industry know that they have this major problem, but we should be bringing them at center stage if we want to address the climate emergency. But it's not, of course, all, because in order to develop AI applications, of course, we need to mine the type of minerals, the type of resources that are actually necessary to produce Internet of Things and the devices that will be powered by AI. And so, we start with the mining and we move towards a major issues that is the issue of e-waste and the issue of disposal. What do we do with this type of devices? What do we do with the technologies that need to be discarded? And at the moment, unfortunately, perpetrating the same kind of pattern of data colonialism that seems clearly dominant, we are currently discarding this type of e-waste in the so-called former colonies. For example, Kenya is one of the biggest e-waste dump venue in the world, but unfortunately we have Bangladesh, we have Cambodia that are used as major e-waste dump. And if we want to really calculate the kind of environmental cost of the type of e-waste and e-dump that we are facing, we should also consider the type of the needs of transportations that at the moment are not matched, precisely because of the incredible energy consumption that also this type of transportation requires, for example. And of course, I'm also listing a fourth way in which we should be really worrying about the impact of AI on the climate emergency, because unfortunately, despite debates that even in Europe are constantly focusing, for example, of the importance, and of course during a tragic war like the one that we're facing, like the banning of weapons, AI-powered weapons in the EU has been a constant conversation. It's been something that has always been as a starting point of any kind of conversation, knowing the need to avoid developing this type of weapons. But what we're missing is a discussion of banning this type of AI application to actually dig fossil fuels, because at the moment, the same companies that are claiming to reduce their carbon emission by making their data centers more sustainable are actually offering the same services to be more efficient to oil and gas companies. And I found this excellent study by Zero Market Research that has showed the level of increase and growth of this field particularly, and the incredible trajectory of growth that will reach by 2025. And so I wanted to give you a clear examples of a different path and the different ways in which we can connect AI with the climate emergency. Now, I mean, I think that criticism always needs a set of solutions to all of these issues. The starting point is that we don't have just one simple policy that we could consider developing to address all of these major issues. But what we could do certainly is to intervene with a sort of a policy toolkit, with a sort of a set of interventions. And I see, and of course we can discuss them in a Q&A, but I see them going into the direction of, for example, demanding the kind of transparency. And I'm arguing, for example, for a green tech label to be attached to devices and tech devices that are being developed on Internet of Things. So, citizens, consumers are aware of the type of carbon emissions of the devices that they're buying. At the same time, I think that we should always consider interventions in terms of, the kind of monopolistic power that the major developers of AI applications are at the moment, achieving. And we know that we're talking about big monopolies, and we know there are ways, also to fragment, also to try to make their power less dominant. And in this way, of course, take back some of the control in the development of these applications, because at the moment we're talking about really major, I call them digital lords developing AI. At the same time, I also, as a scholar, as an academic, I always believe in major interventions for example, literacy. And when I have these conversations in lectures, I see the way in which students react and their curiosity and the need to raise awareness in this field, because we need more research being carried out, but we also need to make sure that students, that school children, for example, are aware of the cost of technology and are aware really of the emergency that we're facing, and therefore can make informed choices. And, of course, these are just a few of the ideas I have and a few of the solutions that I developed. And if you're interested in reading more in the book, Is AI Good for the Planet? And I'm always, happy to, of course, take questions now. But I think that the crucial question that we should really ask at this point, facing the emergency that we're facing, is what are the values that should guide AI development if we want to address the climate emergency. And in order to address the climate emergency, we should place the climate emergency at center stage. And I hope that I clarified how we should do that, and what kind of definition, what kind of understanding of AI we need to move forward in this direction and make sure that we really seriously address the type of limit situation that we're facing. Thank you very much.
Thank you very much. I will now open the floor for questions, and I'll be monitoring chat if you'd like to share your question in chat as well. And I might start with one to begin with while everyone's gathering their thoughts. I'm kind of curious. There's for an AI system, there's the environmental impact, which you've just shown can be quite significant. There are other possible impacts, positive or negative, for a given application of for a given AI. Okay, we're going to use that broad term. I'm wondering how you would think through how to balance those impacts. For example, if you have a case where you are going to be developing an algorithm that is going to provide some kind of social benefit, but it's going to be environmentally costly. Like, how would you think through that? And how could you, like, what's your vision for how we as a society should be doing that kind of, work?
Yeah, it's a very good question, and also a question that I keep asking myself. So how do we do that once we are facing, a situation where we really see the benefit, the social benefit of an application? I think that actually, and this is an answer that I'm giving you because I discussed this with a few AI developers and engineers. So they admitted that they're not fast enough in developing the kind of sustainable neural networks that they could develop. So, and I said, okay, so how can we help? What can we do as scholars, as policymakers? And the idea is that what we need to do is to really demand that this type of more sustainable networks are developed fast. Because at the moment, we know that it is a possibility, but we also know how difficult it is to have clear quantification of the type of computational power, while all engineers I spoke to told me and explained to me that they can do it, and they can actually tell us what is the computational power. So I actually am firmly convinced that it is possible, but we need, as a society, to push for it much more. And because we don't have much time. So that's the issue. So I was saying, okay, so when do you think that you could develop the type of incredibly sustainable neural network to reduce completely the computational power? We said, well, maybe in a decade, 8 years, 15 years. We don't have that kind of time. So it is very important that we push, to act now. And, I still believe in intervention of policy to do that. And so I hope that I answered your question.
Yeah, no, thank you very much for that. I see, Fred, you have a question. Would you like to ask it?
Yes, so a very nice talk, very stimulating, raises lots of good questions. There are always trade-offs in these things. So for instance, we had in the US and elsewhere, a lot of emphasis on the smart grid and intelligent use of energy in the homes managed by algorithms and machines of one sort or another. And for those who installed such systems, there were serious concerns about privacy, to the point where when we monitored our electricity use, we could tell, even to the extent, what movie we were watching. And so there are trade-offs with all these things. So how do we can't just, so that's more of a comment that maybe I'd like your response to. We can't just limit the issue of climate and energy and pollution and so on, when we have other things as well that are important. And so how do you address those trade-offs?
Yeah, well, I think that actually I became convinced that, considering the warnings of the IPCC, and let's remember that the IPCC is quite conservative. So, when they issue the reports that they issue, it means that the consensus is over the 100 that they claim, and they, as scientists, they will never claim to have reached over 100, right? It's typical to say it's 98%, 99% agreement. Like, we are reaching this limit situation. And at this point, I think that I'm sure that all of you that experienced recently a variety of types of weather events, for example, in the US, the constant cyclones, in the South, in Germany, the floods that we never saw, in Southern Europe, constant bushfires, in Australia, bushfires, Nina, and constant floods. Like, we then see what is the public interest and what is it that we should be looking at. And I think that if we think in this way, and this is why I spent so much time trying to really redefine AI in order to make a connection with the climate crisis possible, because very often we understand technology in a way that is really only given to us as sort of a tool to fix something. Well, technology is not a tool to fix something. Technology is social. So if our societies are facing this limit situation, this climate emergency, then that should be placed as center place. And so it might be that there are some applications that we can't afford anymore. and not just for privacy concerns, but because we're facing this limit situation. And we're not where we were in the 90s, where, we were constantly listening to, Negroponte and Gilder telling us that we were reaching a new era of democracy thanks to the internet. Now we know that that didn't happen, and we know what is the path that we should be following in developing these systems that can help, but it can also be very detrimental. So what are the applications that we really need, and what are applications that we could discard? Because there might be an argument that, having Alexa powering all our homes, if that is not necessary and it's too costly in areas that are constantly subjected to floods and to weather events, where data centers could be flooded as well, like maybe we should rethink. And I think that we can do that.
Thank you, Alexis. I see your hand up, sorry.
No, okay, now it's, thanks for this presentation. First of all, I would not talk about artificial intelligence, because what you are talking about is essentially the development of computer science. So artificial intelligence is a very small part of what you presented. So I don't see something specific in artificial intelligence. Data centers or whatever we consume in computing is not specially related to AI application uses. Smart grids and things like that are not necessarily artificial intelligence applications. And the impact on the environment of using, let's say, some sort of algorithmic support on how we run our business is much much older. Just to consider an example.
It's old, of course.
Consider an example. The traveling industry, has been changed dramatically since 30 years because of the introduction of yield management by American Airlines 30 years ago. Now, I'm not going to discuss whether it was positive or negative. It had positive impacts because yield management lowered the prices of the tickets, but it has a negative impact because it increased very much the number of flights we do and the use of not that much, let's say, sustainable traveling way, which is flying. Although increase the freedom of moving around, which is done by flying. Now, the problem is that there is no single way to establish what it is a common priority for everybody. Because even the climate change or the emergency you are talking about, it will not be considered as a priority by everybody. Would you be ready to say that we are, just to come back to traveling, that in order to lower emissions, we should travel less?
Well,
and
I
that
think
we
that
should,
actually...
and that we should constrain the freedom of traveling of people so that we consume less.
Well, I think that, well, firstly, the important thing is what I wanted to focus on was AI, because I wanted to explain how AI also works. And, it's not just the algorithm, but the way in which AI is linked to technological application is something that we should be thinking about. Because, we wouldn't have seen and you're right, like the development of computer science is very old, but the acceleration due to the data extractionism and the data capitalism that we have developed in the last 10 years has been exceptional. And this is why there has been a peak in the applications, right? Now, if you compare the kind of computational power that we use to the travel industry and to the type of carbon emissions attached to the travel industry, you will see that actually we have even a bigger problem with the type of technological developments, but we never question them, while travel and the travel industry are always at the center of debate. Now, what kind of society do we want if we know and we want to admit that we're facing this climate emergency and we want to do something about it? So perhaps going back to reduce the type of travels, but also like really thinking seriously about the trade-offs of this type of technology is the way forward. So I would say, I mean, we could also set a limit and say, okay, like our travel carbon footprint should be, not over this type of thresholds. And there are a lot of institutions that are currently doing that. At the same time, we could also have a tech carbon footprint that we should be establishing, because also the type of technologies we are developing, because of the way in which we are developing it, is creating this problem. Now, the thing is that in the 50s, when we started developing artificial intelligence and talk about artificial intelligence, even though it was around even before then. And of course, there are a lot of history books about technology that are talking about Ada Lovelace, for example, in the development of AI thinking back then. But if you look at the major acceleration of the latest decade, at the same time in which we know and we have all evidence of the climate emergency, well, why don't we start really talking about it? Because talking about green recovery through digital technologies, when digital technologies has this extreme carbon footprint, well, I mean, shouldn't we debate the type of carbon footprint that technology has before we talk about the green recovery through technology? I think we should.
Thank you, Benedetta. I had one last question. You mentioned a series of possible interventions in sort of addressing this kind of issue. Green tech labels, et cetera. This brings me to the thought of leverage points. And I'm wondering if you have a sense of what are likely to be significant leverage points for kind of influencing how we think about the technology that we use and develop, when and how we use AI for a given purpose. What kind of leverage points should we be looking at? And what do you think we should be putting in place?
Well, I think that actually the starting point should be having a conversation about it. I find that whenever I am invited to panels of environmental scientists, they struggle to understand how technology works. And so it's difficult to get them engaged very much with this topic. At the same time, when we are discussing in AI fora, that are academic fora, AI, a conversation about the climate crisis seems very far away. So I think that actually, in order to reach, a leverage point, I think that we should start having these debates, and we should really start demanding, for example, in the context of COP27 that is about to happen in Egypt, we should, as academic, push for a debate around this theme in that context. Because I think that one of the most difficult issues, and for me, it's been really a journey of the last 10 years when I started investigating the data-driven communication impact on the environment. Because if you're trained, as I am, as a lawyer, but also as a social scientist, issues around the environmental impact are far away from our training. And I think that because we establish and we're trying to bridge this divide, I think it would be very relevant to keep having the kind of interdisciplinary conversation that could really help us move forward. Because at the moment, what I can tell you in a very clear way is that the industry is very aware that they have an issue. And I spoke to Microsoft, I spoke to Amazon executives. They know that they need to do something on the neural networks impact, on the computational impact they have, and on data centers, they are aware of it. But if we don't develop the kind of discourse around this that should come from the academy, but that should move into policy fora, I think we'd be lagging behind, and we don't have much time. So the problem is, the apocalyptic image of big new data centers that are, like being in a way like destroyed by big floods, because this is what we are experiencing, right? And so this is why it is relevant to really have this kind of conversation at center stage.
Wonderful. We are pretty much at time, but I have got one last question in the chat, so I will ask that if that's okay, if you have time. And then we will close it for tonight. The question is from Tom, and he says, why can't we regulate or tax the pollution or the CO2 emissions caused by production, use, decommissioning of AI, like we regulate or tax other sources of pollution?
Well, I mean, I think it's a promising idea. I think what would be important would be to really identify in the production chain what are the cost of each, of the section of the production chain. This is why it can be complicated, because you need to have an intervention that comes from a policy or a regulatory authority, right? So you need to make sure that we know very well what are the single sections that are generating, the kind of problematic carbon emissions of each, and then address each of them, right? And this is the challenge, of course. But I know that there are ways, and there are engineers, and there are AI developers that have this data, and are very happy to share this data. And by working together with people that are involved in the different stages of this production, we could certainly achieve the kind of result that we want. It's just that we need really in my view, we really need to recenter the debate, because unfortunately we don't have the 50 years that we had in the 50s when debates around AI were starting taking place.
Wonderful. Well, thank you so much for the talk, Benedetta. I really enjoyed it. And thank you everyone for the discussion today. I really appreciated all your questions. Can we all thank Benedetta for an excellent talk, either with your little
Thank you.
reaction.
Thank you for the invitation.
And no worries, it was lovely to have you. So I'll now close today's session. So I'll share a couple, I'll just share one set of slides to do that. Thank you so much, Benedetta.
Bye. Thank you.
Okay, I'm just going to share these slides. So we had a wonderful set of events today, and I just wanted to give you a brief preview for our events for tomorrow. So tomorrow we'll have a case study designed to help us explore the futures of bushfire responses, both here and abroad. A contribution panel chaired by Professor Fred Roberts from DIMAX, featuring Pia Andrews, Caitlin Bentley, and Ksenia Moyoya and Ned Cooper. We'll also have Solon Barakis joining us for a keynote talk entitled Unavoidable Tensions in Explaining Algorithmic Decisions. I'm really looking forward to this program, and I hope you all are too. Thank you so much for your attention and participation today. We really look forward to seeing you tomorrow. And in the meantime, have a good day, afternoon, or night, whatever time it is for you. Thank you very much.